Hi guys, today we're looking at triangles. By the end of this lesson, you will be able to solve for unknown angles using our triangle theorems. A triangle shown could be called triangle ABC, or using the symbol for a triangle, ABC. The triangle's sides and angles can be marked to give us some information about the triangle. In the diagrams below, we talk about how these markings are used to indicate certain properties. In the first one, these three lines show that all three sides are the same length. If we use the same symbol for our angles, it means that all angles are the same size. The two sides marked are the same length in picture 3, and the two angles marked are the same in picture 4. There are three types of triangles based on their side lengths and angle sizes. An equilateral triangle is a triangle where all sides are the same length and all angles are the same size of 60 degrees. An isosceles triangle is where two sides are the same length and two angles are the same size. A scalene triangle is one where there are no sides the same length and no angles the same size. Please pause and take down this table showing our three types of triangles. Another type of triangle is called a right angle triangle. A triangle is a right angle triangle if one of its angles is 90 degrees. The opposite side of the right angle is called the hypotenuse. Please pause and take this down. A right angle triangle can be an isosceles triangle or a scalene triangle. This means that the other two sides can be the same length or they can be different lengths. It can never be an equilateral triangle. Theorem 2 states that in an isosceles triangle, the angles opposite the equal sides are always equal in measure. Please pause and take down this theorem. Here we have an isosceles triangle. If the length from A to C is equal to the length from A to B, then angle B is equal to angle A, i.e. the angles opposite the equal sides. So here the angles are opposite our equal sides. So the angles opposite the equal sides are the same. Angle A is equal to angle B. Please pause and write down this diagram. Conversely, if two angles in a triangle are equal in measure, then the triangle is isosceles. So here we're told that our angles are the same, which means that the opposite lengths are equal. If we're told that angle B is equal to angle A, then our opposite sides to these angles, that's A to C and A to B, are also equal. Theorem 4 states that the angles in any triangle will add up to 180 degrees. This means that angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. Please pause and take this down. Let's use Theorem 4 that the angles in a triangle add up to 180 degrees to solve the following question. Let's look at question 7 in your textbooks. Find the value of angle A in each of the following triangles. Let's look at triangle A. The three lines on the sides tell us that all of the sides and all of the angles are the same length and size. This is because it is an equilateral triangle. An equilateral triangle has equal sides of 60 degrees. Let's look at number B. We want to find the unknown angle A. From Theorem 4, we know that 50 degrees plus 80 degrees plus angle A is equal to 180 degrees. Here we want to find our unknown angle. We want to solve for A. Let's add together our like terms. 50 plus 80 gives me 130. 130 plus A is equal to 180 degrees. To find our known value of A, we're going to subtract 130 from both sides. A is equal to 50 degrees. Let's look at C. Here we have a right angle triangle. To find our known A, we know that all angles equal 180 degrees. This means that 25 plus 90 plus A is equal to 180. Let's add together our like terms. 25 plus 90 gives me 115. So 115 plus A is equal to 180 degrees. To find what A is, I need to subtract 115 degrees from both sides. We're left with A is equal to 180 minus the two other sides of 115. A is equal to 65 degrees. In part D, we have two sides that are the same length. This means that opposite angles will be equal. Okay, so this angle in here will be the same size. We know that our triangle is equal to 180 degrees. So this means that angle 30 degrees plus our two unknown angles, which are the same, equals 180 degrees. To find our unknown angles, I will subtract 30 from 180 degrees. This means that our two unknown angles, which are the same size, equal a total of 150 degrees. If both angles are the same size and equal 150 degrees, to find one of the angles, we divide our value by 2. A is equal to 75 degrees.